Grab your morning coffee and settle in. We're diving deep into Formula One's most transformative era. Auto Intelligence is produced by Auto-Agentic AI, and I'm Steve, here with Claire to explore how F1's regulatory perfect storm from 2020 to 2025 is reshaping not just motorsport, but the entire automotive landscape.
That's right, Steve. New episodes drop every Tuesday, Thursday, and Saturday. Today, we're unpacking something that should fascinate everyone in automotive. Formula One has become this incredible technological crucible where solutions to global mobility challenges are being pressure tested under the most extreme conditions imaginable.
And what makes this so relevant for our audience is the speed of technology transfer. We're not talking about innovations that take a decade to reach commercial applications. These breakthroughs are finding their way into the vehicles and systems we're all working with within 18 months.
Exactly. So let's set the stage with what I'm calling the regulatory perfect storm. From 2021 to 2026, we've got three massive pressures hitting simultaneously. The $135 million cost cap introduced in 2021, the 2022 aerodynamic revolution reintroducing ground effect principles, and the 2026 power unit mandate requiring a fundamental shift toward electrification.
This triad has created what industry analysts describe as an innovation density 3 times higher than the 2014 hybrid introduction. Formula One has literally become the automotive industry's most concentrated research and development laboratory. When Mercedes-AMG high-performance powertrains achieve thermal efficiencies exceeding 50%, that's not just a racing milestone, that's a roadmap for hybrid powertrains that surpasses most road car engines by 20 percentage points.
Let's dive into that 2022 aerodynamic revolution first, because the ground effect revival wasn't just about making racing more exciting. The FIA aimed to address one of modern racing's most persistent challenges, the inability of cars to follow closely due to turbulent, dirty air.
Andrew Green, Aston Martin's chief technical officer, described the development challenge as nerve-wracking. He said, and I quote, "It was a massive change in regulation to roll back to a ground effect car. That meant our winter has been one of the most challenging we've ever had."
The technical complexity was immense. Teams had to abandon decades of accumulated knowledge about complex front-wing designs and intricate bargeboard systems in favor of generating downforce, primarily through carefully sculpted underbody tunnels. The modern implementation uses fully shaped underfloor channels with strict dimensional tolerances to create low-pressure zones that effectively suction cars to the track surface.
And the results validated the FIA's computational fluid dynamics predictions. Pirelli data revealed 785 overtakes in the 2022 season compared to 599 in 2021. That's a 31% increase that exceeded even optimistic projections.
But it wasn't without challenges. The phenomenon known as porpoising, rhythmic bouncing caused by aerodynamic stalls in the ground effect tunnels, plagued several teams throughout 2022. Mercedes driver George Russell described the sensation as being shaken violently, with vertical forces exceeding 5G in extreme cases.
Which brings us to the next evolutionary leap, arriving in 2026 with active aerodynamics. This fundamentally changes how cars manage the eternal compromise between downforce and drag. The system, designated as X mode and Z mode configurations, represents the most sophisticated aerodynamic control system ever implemented in Formula One.
Jason Somerville, the FIA's head of aerodynamics, explained the rationale perfectly. He said, X mode gives high top speed, while Z mode provides downforce for braking and cornering. Drivers can switch between modes in designated zones, balancing performance and energy efficiency.
Unlike the current drag reduction system, which only modifies the rear wing when a driver is within 1 second of arrival, the active aerodynamic system allows strategic deployment throughout the lap based on track position and energy management requirements. The system targets a 55% reduction in drag while maintaining 70% of current downforce levels.
The technical implementation is fascinating. In Z mode, the front wing's outer sections angle downward, while the rear wing maintains its maximum angle of attack. When transitioning to X mode, the front wing elements raise, while the rear wing's upper flap opens, reducing the overall chord length by 30%.
Somerville noted that the energy management challenges posed by 2026's hybrid power units necessitated this aerodynamic evolution. He said, if you drop the 2026 power unit into a current car, the drag would cause severe speed drop-offs on straights. Active Aero aligns aerodynamics with the power unit's characteristics.
Speaking of those power units, let's talk about what might be the most fundamental change to Formula One propulsion since the introduction of turbocharged engines in the 1980s. The 2026 power unit regulations represent a complete paradigm shift.
The current generation, introduced in 2014, combines traditional combustion with two energy recovery systems, the MGU-K, which harvests energy during braking, and the MGU-H, which captures waste energy from exhaust gases. Mercedes-AMG's achievement of thermal efficiencies exceeding 50% stands as a remarkable engineering milestone.
To put that in perspective, most road car engines achieve thermal efficiencies of 25 to 35%, while the most advanced production hybrids reach approximately 40%. This 50% threshold means that half of the fuel's energy content is converted into useful work, a figure that seemed impossible just 2 decades ago.
But the 2026 revolution changes everything. The MGU-K's output will increase from 120 kilowatts to 350 kilowatts, effectively tripling the electrical component's contribution to total power output. This creates a near 50-50 split between internal combustion and electrical energy.
And they're eliminating the MGU-H system entirely, which reduces complexity but creates new challenges in energy management. The revised energy store battery must handle rapid discharge-recharge cycles, as the MGU-K's increased output demands 3 times the electrical energy of current systems.
Stefano Domenicali, Formula One CEO, has emphasized the importance of competitive parity in the new regulations. He stressed that the system must allow manufacturers to catch up quickly if they fall behind, saying, "We can't repeat Mercedes' 2014 dominance."
The sustainability aspect centers on 100% sustainable fuels derived from bio-waste and synthetic sources. These drop-in fuels, compatible with existing internal combustion engines, offer a potential pathway to decarbonize the estimated 1.2 billion ICE vehicles expected on roads by 2030.
However, concerns persist about the practical implications. Christian Horner, Red Bull team principal, has warned of potential energy depletion on power-sensitive tracks like Monza, while Toto Wolff dismissed such fears as a joke. The FIA is investigating adjustments to battery deployment rules to mitigate these risks.
To address overtaking challenges in the new electrical era, the 2026 regulations introduce manual override mode, a sophisticated energy-based overtaking aid that replaces DRS. When within 1 second of a leading car, the chasing driver can deploy MOM, which extends MGU-K output to 337 kilometers per hour versus 290 for the leader.
Now let's talk about the data revolution, because modern Formula One cars function as mobile data centers. They're equipped with 300 to 400 sensors that monitor everything from tire pressure fluctuations to aerodynamic load distribution across the car's surface.
Each car generates approximately 1.1 million data points per second, creating a data stream that would overwhelm traditional processing systems. The telemetry infrastructure relies on a hybrid wireless network, combining WiMAX for trackside communication and satellite links for intercontinental races.
During the 2023 Las Vegas Grand Prix, T-Mobile's 5G network reduced data latency to milliseconds, enabling real-time strategy adjustments that can determine race outcomes. McLaren's partnership with Dell Technologies and Google Cloud exemplifies this integration. Their RaceWatch platform processes over 1 terabyte of data each race weekend.
The application of artificial intelligence extends far beyond data collection to predictive analytics and strategic decision-making. Red Bull Racing's partnership with Oracle enables the team to run 8 billion race simulations before each event, using Monte Carlo methods to evaluate every possible strategic scenario.
McLaren's AI systems have achieved a 92% accuracy rate in automatically flagging track limit violations, reducing the workload on human stewards while ensuring consistent enforcement. The FIA's track limits computer vision system has reduced manual video review workloads by 40% during Grand Prix weekends.
But the 2023 British Grand Prix demonstrated the limitations of pure AI decision-making. When unexpected rain began falling, human strategists outperformed AI models by an average of 11.3 seconds per pit cycle, highlighting the continued importance of human intuition in unpredictable scenarios.
You're listening to Auto Intelligence, brought to you by Auto Agentic,
the platform transforming automotive retail with intelligent, human-centered AI.
Now back to today's topic.
Looking toward 2026 and beyond, generative AI is beginning to influence car design and component optimization. AWS's collaboration with Formula One includes using generative AI for designing lightweight components and aerodynamic profiles, accelerating development cycles that traditionally required months of wind tunnel testing.
Predictive maintenance represents another frontier where AI is transforming operations. Machine learning models can forecast mechanical failures by analyzing vibration patterns, temperature fluctuations, and performance degradation trends. For the torque-heavy 2026 engines, these systems will be crucial for preventing turbocharger failures.
Now let's dive into Formula One's sustainability revolution, because this represents one of the most ambitious programs in professional sports. Formula One's commitment to achieve net zero carbon emissions by 2030 is backed by measurable progress. They've already achieved a 13% reduction in their carbon footprint between 2018 and 2022.
The sustainability strategy focuses on three interconnected pillars: achieving net zero carbon emissions, leaving a positive legacy for communities, and building a more diverse and inclusive sport. The carbon reduction efforts target the sport's three largest emission sources: logistics at 45% of total emissions, facilities and events at 30%, and business travel at 25%.
DHL, Formula One's logistics partner since 2004, has deployed 37 biofuel-powered trucks for European races, running on hydro-treated vegetable oil. This initiative reduces emissions by 83% compared to diesel, equivalent to removing 340 cars from the road annually.
For intercontinental freight, DHL utilizes Boeing 777 aircraft, which are 17% more fuel efficient than older models, and has increased the use of sustainable aviation fuel to 20% of flights. The calendar optimization strategy groups events by region to minimize travel distances.
McLaren Racing's 2024 partnership with Ecolab funded 1 million gallons of SAF, covering 100% of its business air travel and reducing per-race emissions by 23%. This demonstrates the scalability of sustainable fuel adoption beyond the racing context.
The development of 100% sustainable fuels for the 2026 power units represents more than just a Formula One initiative. It's a potential catalyst for global automotive decarbonization. These fuels, currently being tested in F2 and F3 cars, reduce life cycle carbon emissions by at least 65% compared to conventional gasoline.
The fuel composition includes second-generation biofuels made from agricultural residues and non-food biomass, avoiding competition with food supply chains. Synthetic alternatives produced via carbon capture and renewable hydrogen offer even greater emission reductions.
The transition to circular economy principles represents perhaps the most innovative aspect of Formula One's sustainability program. McLaren, in partnership with Deloitte and the FIA, has developed the F1 Constructor Circularity Handbook, a comprehensive framework for measuring material inflows, waste streams, and recycling rates across the sport.
Carbon fiber recycling presents both the greatest challenge and opportunity. Traditional carbon fiber production emits 29 tons of CO2 per ton of fiber, and recycling has been limited due to technical barriers. Mercedes-AMG Petronas is pioneering sustainable carbon fiber integration using recycled fibers and bio-based epoxy resins in its 2025 chassis.
McLaren's trial of recycled carbon fiber at the 2023 U.S. Grand Prix demonstrated a 27-ton CO2 saving per ton of material, paving the way for a fully circular F1 car by 2030. The Circularity Handbook mandates teams to track metrics like material circularity percentage, with McLaren achieving 37% in 2024.
Event sustainability extends beyond materials to operational practices. The Australian Grand Prix diverted 91% of event waste from landfills in 2024 through composting and recycling, while the British Grand Prix powered its entire operation via 2,746 solar panels and HVO generators.
Looking toward 2030, the vision is compelling. The 2026 regulations mandate a 30 kilogram weight reduction to 768 kilograms, achieved through simplified hybrid components and lighter energy storage systems. Dimensional changes include a 200 millimeter reduction in wheelbase and 100 millimeter reduction in width.
These changes aim to reduce cornering speeds by 10 to 15% while maintaining lap time parity through improved acceleration and top speed. The smaller, lighter cars should exhibit more go-kart-like handling characteristics, reminiscent of the 1990s era that many consider the pinnacle of driver-focused racing.
The technology transfer from Formula One to road cars has accelerated dramatically during the 2020 to 2025 period. Battery innovations driven by the 2026 power unit requirements are already influencing electric vehicle development. Solid-state battery research could reduce EV charging times to 10 minutes by 2030.
Active aerodynamic systems, tested under Formula One's extreme conditions, are finding applications in commercial vehicles. Porsche and Tesla are testing adaptive wings derived from X-mode systems, promising fuel efficiency gains of 15 to 20% for long-haul trucking.
The AI and machine learning systems pioneered in Formula One are being adapted for autonomous vehicle development. Predictive algorithms that forecast tire degradation and mechanical failures in racing are being modified to predict maintenance needs in commercial fleets.
As artificial intelligence becomes increasingly sophisticated, Formula One faces a fundamental question about the role of human drivers in an automated world. Current FIA regulations explicitly ban autonomous driving aids to preserve driver skill, but the line between assistance and automation continues to blur.
AI copilots could revolutionize in-race decision-making by providing real-time analysis of energy deployment opportunities, optimal racing lines, and strategic recommendations. However, implementing such systems while maintaining the sport's human element requires careful balance.
The technologies developed in Formula One's innovation Crucible are rapidly finding applications across the automotive industry. The thermal efficiency breakthroughs achieved by Mercedes-AMG HPP are informing the development of next-generation internal combustion engines for hybrid applications.
Electric vehicle manufacturers are closely monitoring Formula One's battery technology development. The extreme charge-discharge cycles required for the 2026 power units are pushing battery chemistry and thermal management to new limits, with direct applications to high-performance EVs and fast-charging infrastructure.
The active aerodynamic systems being developed for 2026 have immediate applications in commercial vehicle efficiency. Long-haul trucking, which accounts for a significant portion of transportation emissions, could benefit enormously from adaptive aerodynamic systems.
Formula One's advanced materials research, particularly in carbon fiber recycling and bio-based composites, is attracting attention from aerospace manufacturers. The weight-critical nature of aircraft design makes Formula One's lightweight material innovations directly relevant to commercial aviation efficiency improvements.
The Sustainable Fuel Development Program has implications far beyond motorsport. The synthetic fuel production methods being refined for Formula One could provide a pathway for decarbonizing sectors where electrification is challenging, such as aviation and maritime transport.
The transition to the 2026 regulations presents significant technical challenges that extend beyond individual teams to the sport's fundamental character. The increased reliance on electrical energy raises concerns about energy management strategies that could fundamentally alter racing dynamics.
The complexity of active aerodynamic systems introduces new failure modes that could affect race outcomes. Unlike current DRS systems, which fail to a safe closed position, active aerodynamics failures could create dangerous handling characteristics.
The cost cap era has fundamentally changed how teams approach technological development. The $135 million limit forces teams to prioritize innovations with the highest performance return on investment. This constraint could actually accelerate technology transfer.
The FIA faces the ongoing challenge of balancing innovation with competitive parity. The 2026 regulations represent the most prescriptive technical rules in Formula One history, designed to prevent any single manufacturer from achieving dominance.
What's your take on the biggest breakthrough we've discussed today?
Honestly, it's the integration of sustainability with performance. For decades, those were seen as opposing forces. But F1 is proving that environmental stewardship and high-performance engineering can be complementary drivers of innovation. The 50% thermal efficiency achievement while moving towards sustainable fuels, that's a paradigm shift that's reshaping how we think about automotive engineering.
I'm most impressed by the data processing evolution and its implications for our industry. The ability to process 1.1 million data points per second and turn that into actionable insights in real time is transforming decision making in high stakes environments. Whether it's race strategy or customer experience optimization in automotive retail, the principles are the same.
And the timeline compression is remarkable. We're seeing innovations move from concept to commercial application in 18 months rather than years. That acceleration is changing how the entire automotive industry approaches research and development.
The regulatory perfect storm we discussed, the cost cap, aerodynamic revolution, and power unit transformation has created an innovation density that's unprecedented in automotive history. But the real test isn't whether these technologies work on track, it's whether they can scale to address global mobility challenges.
The early indicators are incredibly promising. Sustainable fuels that could decarbonize billions of existing vehicles, active aerodynamics that could revolutionize commercial transport efficiency, AI systems that could enhance both performance and safety across multiple industries.
Formula One has always been about pushing boundaries, but this era is fundamentally different. It's not just about going faster, it's about going faster while solving some of the automotive industry's most pressing challenges. The sport's technological crucible is forging solutions that could benefit not just motorsport, but mobility itself.
And that's what makes this so relevant for everyone working in automotive. These aren't just racing innovations, they're blueprints for the future of transportation. The technologies being pressure tested under the most extreme conditions are creating pathways for sustainable, intelligent, and efficient mobility solutions.
As we head into 2026 and beyond, Formula One's role as an innovation catalyst is only going to intensify. The technologies being developed today will define the next decade of automotive development, from the dealership floor to the global supply chain.
The legacy of this transformation extends far beyond the paddock. As sustainable fuels power the next generation of vehicles, as active aerodynamics optimize commercial transport efficiency, and as AI-driven systems enhance both performance and safety, Formula One's technological crucible will have fulfilled its ultimate purpose, forging solutions that benefit not just motorsport, but mobility itself.
The next 5 years will determine whether Formula One's technological gamble pays off, whether the sport can maintain its competitive spectacle while pioneering solutions to some of the automotive industry's greatest challenges. The early indicators suggest that the crucible is working, transforming pressure into progress and challenges into opportunities for breakthrough innovation.
Thanks for diving deep with us today. The intersection of performance and sustainability in Formula One isn't just changing motorsport, it's reshaping how we think about the future of automotive technology and what's possible when innovation meets environmental responsibility.
Before we wrap up, let's talk about what we're building here at Autoagentic. The Formula One innovations we've discussed today, the AI-driven decision-making, the real-time data processing, the predictive analytics, these same technologies are transforming automotive retail right here, right now.
That's exactly right, Steve. Autoagentic is pioneering AI-driven solutions specifically designed for the automotive retail industry. We're not just talking about generic AI tools, we're talking about intelligent, adaptive systems that understand the nuances of dealership operations, customer behavior, and the complex sales processes that define automotive retail.
What sets Autoagentic apart is our human-centered approach. Just like Formula One is finding that balance between AI assistance and human expertise, we believe the future of automotive retail isn't about replacing dealership teams. It's about empowering them with intelligent tools that enhance their capabilities.
Our platform features over 90 modular agents. Think of it like Formula One's telemetry systems, but for your dealership, processing thousands of data points to help you make better decisions in real time.
We're LLM agnostic, which means we're not locked into any single AI provider. We can adapt and integrate with whatever technology works best for your specific needs. And just like Formula One teams work closely with OEMs and technical partners, we collaborate directly with dealer groups and OEMs to ensure our AI implementation is practical, effective, and aligned with real-world business goals.
What truly differentiates us is our deep understanding of the automotive industry. We're not a generic tech company trying to apply AI to automotive. We're automotive specialists who happen to use cutting-edge AI. We understand the regulatory environment, the customer journey, the seasonal fluctuations, and the operational complexities that make automotive retail unique.
Our consultative approach means we don't just deliver technology, we deliver strategic guidance. True agentic AI isn't just about automation, it's about strategic thinking, collaborative planning, and operational integration. We help dealerships not just implement AI, but transform their entire approach to customer engagement and operational efficiency. Because at the end of the day, automotive retail is about people. The customers who trust you with one of their biggest purchases, and the team members who make that experience exceptional. Our AI enhances those human connections rather than replacing them.
That's why we call ourselves the most human AI company in automotive retail. We don't just deliver tech, we deliver trusted guidance that helps dealerships thrive in an increasingly competitive and complex market.
If you're interested in learning more about how AutoAgentic can transform your dealership operations while maintaining that essential human touch, visit us at autoagentic.ai.
And remember, just like Formula One's innovations eventually make their way into the cars we all drive, the AI technologies we're implementing in automotive retail today are setting the foundation for the customer experiences of tomorrow.
This episode was produced by the team at AutoAgentic. Once again, you can learn more at autoagentic.ai. We'll look forward to you joining again on Saturday.